Hello and welcome back to another lecture from organic chemistry. In the last couple of lectures, we went through mass spectrometry, and I showed you how to use fragmentation to find the structure of unknown samples. And we practiced a good number of questions there. Also, you can actually zoom on the pattern between the molecular ion and M+1 or M+2 to figure the unknown sample, whether, for example, it has a chloride, bromide, or fluoride. And as you see, for carbon, nitrogen, oxygen, or fluorine, we are dealing with one, we can say one technically the isotope, and it's mainly carbon 12 for nitrogen 14, oxygen 16, fluorine 19. They're almost 100%. And when it comes to chlorine or bromine, we have two isotopes. So, for example, in case of chlorine, 75% or 76% is a chlorine, 35, and 24% chlorine 37. And so the mole, as I said, the ratio between them is going to be, you can say, is 3 to 1. What does it mean? It means I'm going to see a peak for M+1 that is a 3 times. It has an intensity 3 times of the M+2. Okay, why? Because it's a 76% of chlorine 37. And in case of bromine, the ratio between them is 1 to 1. So the ratio, the like intensity of the M+ peak and M+2 is going to be 1 to 1. Okay, for example, in this case, let's assume they decided to hide, hide the M over Z. They hide those two, and they are asking you assign them. Okay, just assign them based on the pattern. And again, let's assume we don't know the M over Z. I'm going to just simply zoom on this area here. Okay, the top one is giving me two peaks close to each other. Like if I decide to call this one M, or let's call it the base peak. And also it will be M plus, or the molecular ion peak. That peak is 3 times of the M+2. 3 times, so 3 to 1. Well, in this case, they are 1 to 1. And so if I call this one M plus, and then that one is going to be the M+2. And so in that case, the bottom one, it will be bromine, because the ratio between M and M+2 is 1 to 1, while the top is 3 times of the M+2. Okay. And here is another example. I have 4 molecules. They gave me the spectrum. I can easily write the molar masses for each one and match it with the M over Z for the, like M over Z of the molecular ion, and assign the unknown, okay, unknown sample, okay. Or okay, for now, I can close my eyes on the molar masses and simply just look to this region. That's going to be M+1. Sorry, that's going to be the molecular ion, and this peak, the one that is 80, it will be M+2. Okay, the ratio between them clearly is not 1 to 1. Okay, clearly is not 1 to 1. And we said oxygen 16 is almost 99%. And how about fluorine? Fluorine 19 is 100%. And so it cannot be oxygen or fluorine. Those are gone. And how about the bromine? In case of bromine, we said they are 1 to 1. But the ratio between these two is not 1 to 1. Clearly, 78 is bigger than 80. And maybe you can say by 2 and a half, but clearly it's not 1 to 1. So it cannot be bromine, it cannot be fluorine or oxygen. Okay, so that way I can actually rule out those 3, and I say it should be a compound that's carrying chlorine. Okay, that's one way to go after it. Now, I want to zoom on this peak. Okay, why do I see 43 as a base peak? Okay. If you highlight those carbons, you can see that in all 4 examples, we have propyl. Okay, and if we decide to cut the molecule or chop the molecule from there, we get a propyl that it has M over Z equal to 43. And that's the reason, we see 43 as a base peak, for the molecule. Next thing is, and how about this 63? Why do I see the 63? Okay, 63. Then if you compare it with the 78, okay, so I go 78 minus 63. That's going to give me 15. So I have a compound that lost 15 from the atomic mass and ended with 63. And 15 is equal to CH3. So we can assume our molecule went through fragmentation. This one happened. So we have a chlorine here. And let's break the molecule from, for example, from here. So in that case, we get CH3 radical plus, okay, again, this one is a radical ion. And plus, we got this. We got 2 carbon, CH3. This one C attached to chlorine. Okay, and also it has one hydrogen attached to it. There is one hydrogen here. So here, that hydrogen carbon, it has a positive charge. In order to stabilize it, we'll have a double bond between the carbon and chlorine. And now chlorine is going to have a positive charge. And this one, it will have M over Z equal to 63. So this is the reason for it. And we show it as M minus 15. Okay. And again, the reason for 43, I said, if you take this compound and remove Cl from it, and so let's say we got this plus this species, M over Z, it will be 43. Okay. Now, let's write the molar masses for all of them. The molar mass for the first one is 78.54. Second one is 122.99. This one is 62.09. And the last one is 60.1. So if you just simply write the molar masses and match it with the molecular ion, clearly you can see the correct answer. It will be the first one, and rest are wrong because the mass, or M over Z, of the molecular ion is 78, and only the first molecule, it has molar mass of 78. I'm going to stop the lecture here, and thank you very much.